Hi, Kim Shepard again. We're going to go over video 4G today. We're going to start looking at the 5-number summary as well as a rule of thumb for determining if you have outliers in a data set. So when we want to compare groups, we can look at histograms to compare and contrast shape, center, spread, and unusual features. And we can use box plots to see how the 5-number summaries differ. So today we're going to go over the 5-number summary. In the next video you'll learn about how to construct a box plot based on information from this video. The 5-number summary is just 5 numbers from your data. It consists of the smallest observation in your data set, or the minimum value in your data set, the first quartile, the median, which is also the second quartile, the third quartile, Q3, and then finally the largest observation in your data set, or the maximum value in your data set. So these 5 numbers represent what's called the 5-number summary for your set of data. So let's look at an example. So during last summer at Cecil College, statistics students reported their age and their gender. And so we have, for the set of females, we have a list of ages for that sample of students. We're going to take this and determine the 5-number summary. The data have conveniently already been sorted for us, so they are in order. And then we'll do the same thing for a sample of male students. So this data set has 24 values in it. We sampled 24 female students. And some of these are extremely easy. The smallest observation, especially since they're ordered for us already, is 18. We need to find out what the first quartile is, what the median is, what Q3 is, and then finally what the largest observation is. Whoops. And again, that's a very easy one too. The largest observation in this set of data we can see is 47. There we go. Okay, for our other values, the median, we have 24 observations, so there are 2 values right in the center of the data set. Those 2 values fall right about here. Let's see and so you know if there's an even number of observations in your data set, you would take the average of the 2 values in the center, and the average of 20 and 20 is going to give us a median of 20. So half of the students were below age 20, half of the students were above age 20. If you take the bottom half of the data, there are 12 observations in the bottom half of the data. And if we look at the 2 observations that fall in the center of the bottom half, they occur about right here. They're again both 19, so we would take the average of 19 and 19, and Q1 is 19. We do the same thing with the top half of the data. There's 12 observations starting here in the top half of the data. And if we look at the 2 values that fall in the middle of the top half of the data, that's 26 and 29. If you add up 26 plus 29, take the average, we'll get that Q1 is 27.5. Come on, pen. There we go. We'll write that in, 0.5. So this would be the 5-number summary for this female data set that consists of their age. Let's do this again for a sample of males that we surveyed during the summer. Maybe. Oh, went the wrong way, sorry. There we go. Okay, so here are the males, and we have their ages. And if we compute the 5-number summary for this data set, this is the smallest observation, 19. Over here would be the largest observation. And again, this data set has 10 observations in it. So there are two values in the center. These two values are right in the middle. So if we take the average of 19 and 20, that would give us the median. And so the median age for these males is going to be 19.5. And then in the bottom half of the data, Q1 divides the bottom half in half. So Q1 is going to be 19. Should have listed the minimum was 19. In the top half of the data, this value splits that in half. So Q3 will be 22. And then the max was 56. So for this sample of males, there's the 5-number summary for those. Now, one of the things that we'd like to look at with this is, these are ages of Cecil College statistics students. The 56-year-old sort of stands out there as looking like a somewhat unusual age there. So we'd like to determine, how do you know if you have an outlier? Certainly if that was an 86-year-old, that would clearly be an outlier. If that was a 36-year-old, would that be an outlier or wouldn't that? So where exactly is the cutoff? So next we want to give you a rule of thumb for determining outliers. Okay, so here's the rule of thumb that we're going to use. Try this one more time. We're going to compute something called fences. And if the values fall outside of the fences, if they fall below the lower fence or above the upper fence, we'll classify those as an outlier. We'll go with this. So values that fall beyond the fences, below the lower fence or above the upper fence, will be classified as outliers. Okay, and how we get those fences, for the lower fence, to determine if you have outliers on the low end, we're going to start at Q1, and we're going to subtract 1.5 times the interquartile range. We abbreviated that IQR. And for the upper fence, we'll start at Q3, and we'll again add 1.5 times the IQR. And any points in our data set that are smaller than that lower fence or larger than the upper fence are considered to be outlying values, outliers. So we're going to return to the data set with ages and see if we had any outliers in those data sets. Okay, so over on the board here I have our 5-number summary already written up for each of these. So let's see if we have outliers for the females. In order to compute those fences, you need the interquartile range. We have the quartiles. So the interquartile range is the difference of Q3 minus Q1. So for the females, we'll take 27.5 minus 19. The interquartile range for this data set is 8.5. And then we can use that to compute the lower fence. We start at Q1 and subtract off 1.5 times the interquartile range. So Q1's 19. And we'll subtract off 1.5 times our interquartile range, which was 8.5. Your order of operations, you're doing that multiplication before you subtract that off from 19. And when you do that, we get a lower fence of 6.25. So if we had any Cecil students that were younger than 6.25, they would be considered outliers. Pretty sure we're not going to have any outliers there on the lower end for the females. Okay, how about the upper fence? And actually, I can tell we don't. We have the minimum value listed right here. Youngest female student was 18. So that tells us there's no outliers on the low end. All right, how about the upper fence? The oldest female student was 47. Let's find out if she's an outlier. So here was our formula. Q3 was 27.5. And we'll add to that 1.5 times the interquartile range, which was 8.5. And if you do that computation, we'll find out that the upper fence is 40.25. Okay, so without going back and looking at the data quite yet, I know I have at least one outlier. 47 is larger than 40.25, so the 47-year-old's an outlier. And if there were any other female students that were older than 40.25, they're also outliers. So we have at least one. 47 is an outlier. And let's check. There was a 40-year-old. They're not an outlier. They're younger than 40.25. But the 45-year-old is another outlier. So the female data set has two outliers. So 45 and 47 are outliers. Let's do the same thing with the data set that has the ages of the males. So here we have the 5-number summary for that data set. Again, we need the interquartile range. Take Q3 minus Q1. The interquartile range for this data set is 3. And now we can compute our fences again. That lower fence starts at Q1, subtract off 1.5 times the interquartile range. So Q1 for the males is 19, minus 1.5 times 3. It's a minus. The lower fence for the male data set is 14.5. The youngest male we had in the data set was 19 years old, so clearly he's not younger than 14.5, so there are no outliers on the low end there. Now let's check on the upper end if that 56 is potentially an outlier. So finally, the upper fence, you start at Q3 and add 1.5 times the interquartile range. So Q3 was 22. And we'll add 1.5 times our interquartile range, which was 3. And this will give us an upper fence value of 26.5. So the 56-year-old was definitely an outlier. And if we take a peek over at the data set again, the 27-year-old is actually an outlier too, just a little bit older than 26.5. So we have two outliers here for the male data set. 27 and 56 are both outliers. In the next video, we'll take this information and we'll put this in something called a box plot so you can sort of visually see the 5-number summary, as well as if you have any outliers in a data set.